everyone. Thank you so much for being here to listen me talking about code smells. This talk is kind of inspired about the sense of when we are writing Elixir code. When I was learning Elixir, I heard about a lot of histories about, the code will be clear, will be simple, everything will make sense, no spaghetti code, but the reality is not usually like that. So I will try to talk a little about this, like how to create a good design with Elixir code and exploring some concepts about it. So I am Elaine, I'm from Brazil. I have an academic background in computer engineering and a master's degree in computer science. I like to mention just this background because whenever I can, I try to mix my academic vision with my daily work. I've been working with software development for 14 years now. I already work with PHP, Java, C++ a little bit, and now I'm working with Ruby and Elixir, 4 years of Elixir in production. And currently I'm a senior software engineer at The RealReal. A quick thing about The RealReal is an online and brick-and-mortar marketplace for authenticated luxury consignment. And I think the coolest part is we are one of the early adopters of Elixir. It has been running Elixir in production for, I think, 7 years now. And there's this cool documentary about the Elixir adoption story. But I'm here to talk about code smells and trying to start mixing this academic background with my daily work vision. I found this interesting article, like, do developers care about code smells? It's kind of old, like 10 years ago, but I think it still makes sense. Like, start with the concerns, like why they should care about it, like how much they care. In that survey, the majority of them was showing some concerns, and most of those concerns were about developer productivity, product evolvability, quality of the end product, and self-improvement. There was this relationship between knowing code smells, knowing how to fix them, with being a more senior developer. And the interesting part for me was the other side, like, who doesn't care at all? And it has they found this correlation between, like, awareness about what are code smells with having no concerns, like out of sight, out of mind. So checking a little bit about the knowledge about code smells, the majority of them never heard about them or heard but not sure exactly what they are. So I will start with the terminology here first, just to put everyone on the same page. Code smells or bad smells or code bad smells are any characteristic in the source code that may indicate a deeper quality problem in the system. Does it mean they are bugs? No, they are not. We are not talking about bugs, and we're not talking about issues regarding, like, breaking the code. We are talking about more symptoms of poor design and implementation choice. What does that mean? Like, when we are talking about a good design, we are talking about a healthy system that can grow up, like, in a consistent pace, and we can have more functionalities over time. And when we are talking about no design or with a system with a poor design, we are talking about a system that can have, like, a fast pace, adding new features, going fast, but there's a point in which we start seeing more bugs than releasing features. We are seeing more tech debts. Then this is, like, the point that good design makes sense, like, if you are thinking about long term. And one specific thing about code smells, if we are not aware of them, we are not fixing them, they may slow down the development and increase the risk of bugs and failures in the future. We are talking about the future, not exactly now. The reference for this concept came from this book, Refactoring. It's an old book, like 25 years ago, and they describe 22 code smells in that book. Most of them focus on object-oriented programming, and the curious part is, like, 18 years later, they release a new version, adjusting some code smells, like renaming a couple of them, and most of them still make sense, even after this many years later. And the curious part is also makes sense for functional programming. And they're just to have an idea about them, like mysterious name, duplicated code. You may have the sense of, oh, okay, I already saw some code smells in your code base. And okay, the code smells are the issue, but how to fix them is in the same book. The name is a spoiler. We are talking about refactoring. And there's for each code smell, there are a list of refactoring techniques that we can apply to fix them. It's a bunch of them. I will not explain all of them, but I will explain what is refactoring, because we already talked about code smells. And I like this illustration because when I started working with refactoring, I had this feeling, okay, I'm just changing things from a place to another, it's just like spreading the mess all over the system, or talking about other colleagues doing some refactorings, and it start like one change, and it start growing until it's like never ends. CI failing for the weeks, and the thing can hard to test, hard to deliver, and this sense like, okay, this is fine, this is happening, this is part of the process, but occasionally like just need to throw it away, and because it's hard to test, hard to deliver, just let it go. The good thing is this is not refactoring, or is not supposed to be refactoring. Refactoring is a controlled technique for improving the design of existing code base. It's about small behavior preserving transformations. And when we are talking about small behavior preserving transformations, we are talking about the observable behavior, like from a client, from a user. We are talking about how the system is observed by the others. And the process is basically like this. We identify the code smell. We decide if it's time to fix it now or later. We apply the refactoring technique and run the test. This is the important part until we move to the next code smell. And I have this small piece of code. And if you may notice, like, there's a lot of small things that we can improve. Like, what are these variables? And this is already a code smell. This is the mysterious name, also called bad naming. Name is hard. And the refactoring here is like just renaming the variable. It is a refactoring technique. And once we rename it, this makes a little more sense. We are talking about cart, so we have products and a discount. And then we run the test, and then we move to the next one because this function name is not good enough. And this is also the same code smell, but here we are talking about calculating totals, and the refactoring here is change the function declaration. We are changing the function name. And for that, we need to find all the old reference, updating those reference. The behavior of the system continues to be the same, only this like calls that we need to update and run the test. And there is another code smell that I noticed is also related to mysterious name, but this is a field like from a map or a structure, and we will skip it for now. And so what we are trying to achieve when we are doing those refactorings, we are trying to create a software that is more maintainable, extensible, reusable, with a more readable code. And it's also a good, when we are like improving performance, we can also call it refactoring. It can be one of the goals. And we are also aimed to have more clarity, like less complexity in our code. So trying to find out code smells, the name was easy one. I think the other one, you may notice, like when we start seeing a lot of if-else's all over the place, and I have this beautiful code here with a lot of if-else's, is Elixir. And this is just a silly way of saying, okay, let me evaluate this weather, temperature in Celsius, because I'm from Brazil. So just to see if it's hot, it's not the hot or not the cold, it's cold. But I'm not in Brazil today, so I have to update it for Fahrenheit. And this code starts to be more messy than it was before, and became hard to read, hard to understand. But we are talking about Elixir, so let's use pattern matching and solve all the problems. This is the version using pattern matching, and they are doing the same. At least it was supposed to be. But I have the same sense of, like, I have the ifs in a different version, like in a different flavor, with functions with multiple clauses everywhere. If we see in both examples, we have duplicated code for this logic about Fahrenheit and Celsius, and many execution paths. Like there's like multiple conditionals that your code can be go through. So when we are thinking about improving that piece of code, I can look at the traditional code smells in the Elixir context, and the quick one is like duplicated code. And the refactoring techniques to improve it is things simple like extract a function, slide statements, and other things. Here we are aiming to make your code like focus on dry, like don't repeat yourself, and single responsibility principle. So make your code, like your rules, in one single place to keep it like easy to maintain, easy to test, and all other things is to make sense on the functional programming side. So in my code, like let's apply the extract function, and that bunch of functional clause can be converted to this simple one here. I only added like extract a function to parse from Fahrenheit to Celsius, and then I will do the same thing, like evaluating, oh, it is hot code, not that hot, that not the code, in one single function here. So this function is for one purpose, the other function is about the other purpose. Another code smell that that makes sense also in Elixir and functional programming is large class. We don't have class, but we can imagine like a module, and there's strategy also like extracting things, moving things here from there, like in that picture. Like, and don't be worried about this gigantic module. If you see, like, we are able to split in multiple places. There's many rules, many business rules that is handled. A lot of pattern matching also. And if it starts growing, it will become hard to read, hard to test, hard to understand, hard to explain what that module does. Like it's kind of God class, God the module. And as I mentioned, like multiple business rules. So one thing that we can do is just extract a class. In this context is a module. Let's extract the module here. And like before we had 4 rules here, and now we have 4, and that's it. Like, we are improving the design a little bit over time, and things will getting better as you go. The other code smell that we can think about is long functions. We are talking about functional programming. Function is like the core. And there's a lot of ways of doing, including replace conditional with polymorphism. This still makes sense. But I won't give any example for that, just because of the time. But I will recommend this book here about the programming brain. Is an interesting vision about how the cognition process, like how you are processing the code in your mental, like in your memory, how it's connected with the programming activities. It will make sense why we should not have long functions, why we should have better names for variables. It is all about how our brain works. I really enjoyed this reading. And this other one is, I think it's a cool one. Hard to find an example, but I hope I did a good job. Like this is a shotgun surgery. When you are doing a small change in your code base that is expected to be small, and then for some reason you start doing the same change in multiple files. Like the logic is not in one single place, and your small PR that should be like one line, it will become multiple files. There's, as always, like moving things around, split, combining things are strategies for refactoring. And I have this same shopping cart example here. Now the focus will be in these two arguments, like into these two maps. They have this logic based on the ID and some random number. Behind the scenes, this represents a subscription ID. I chose it for simplicity. But like for that subscription, we have a discount associated for the example for a product and a different shipping rate. And someone in the product side can say, okay, let's add a new subscription. And it's simple like, oh, adding 2 new lines here. And with some different discount rates, but it's fine. And then you do a global search and find another place that requires another small change. And you start doing those small changes all across the system. So one thing to do, like, not sure if exactly the best name here, like moving field, but we can encapsulate the logic instead of spread across of the files. We can consolidate it in one single place. And my idea here was using a structure to have this configuration for each ID. We have a different price for the renewables renewal subscription, and the shipping tax and discount rates, all things here. If we go back to that subscription renewal, we can do something like delegating the logic to that structure. And for that multiple functional clauses that we can have based on the ID, we can simply delegate from, like, getting that information from the other place. Like, we are encapsulating that logic. Like, we are moving the rule from the shopping cart to the place that it should have it, like in the subscription context. One important thing here is all these examples are illustrative for illustrative purpose. I swear I never did that in production. But one thing that I'd like to call out is like, be mindful about issues with using floats for monetary calculations, not only for Elixir, okay? I was using the float for that. There's no issues about floating in, like floating point numbers is already in the documentation. And things like that, like if you are expecting the first statement to be true, it's false because of this loss and precision during roundings. I strongly recommend you to read more about it. And this is like I think the special part of this talk. We are talking, not all traditional CodeML are applicable to the Elixir context. And if we see that list, the updated one, we will see like, I think it's 12 or 11, I don't remember. That makes sense, and I know that because of this article, this scientific research in progress about CodeMLs in Elixir. It's a research from Brazil, from Federal University of Minas Gerais, and it is conducted by Professor Lucas Vegge and Professor Marcos Valente. They are researching about the CodeMLs specifically in the Elixir context. And when we are talking about those CodeMLs, we are talking about these suboptimal code structures that can harm the internal quality of the Elixir systems. And they found so far 14 designer-related SML and 90 low-level concern SMLs. That research was based on surveys and repository open source data, and they have developers from all over the world, mainly from America, replying about like what are the CodeMLs they are seeing in their daily work. All this data is publicly available, is on GitHub as a catalog of Elixir-specific CodeMLs. This is code we can use LiveBook for first running the examples, and I will talk about like a few of them. One specific CodeML related to design is the unrelated multiple clauses function. kind of similar, the examples I already showed. It's not an issue, like it's not a code smell using multi-clause functions in Elixir, but it is when we are grouping, we are just using two group functions, but that are unrelated, like group things that are unrelated. Let me show some examples here. We have here 4 clauses, function clause here, and we actually can group in 3 groups. One like updating user stuff, email, and the other one is for a payment method, and the other one is for notification. And the refactoring here is simply like, let's create a new function. And having this focus on, okay, having one single purpose for that function is apply one single responsibility for the module. We can talk about that also for functions. The payment method is another function, and the notification will be another one. And the second smell I'd like to mention is the compile time global configuration. Sometimes you will see some module attributes that are defined at compile time using data from the application environment that may not be available in memory during compile time and building time. Thanks to Elixir, it raises a warning about that or an error. But it is using things like that, like we have this parts that is a product module, and it is fetching data from the environment, from the application, and we'll see an error about that. And the easy way to fix it is like using the compile wave with a default value, but be mindful about configuration for compile time and runtime. There are some cool documents about that. And just going to some examples for low-level concerns. One is about complex else clauses in with. When we have that with statement, with else, it's not a code smell when it's simple, but when it starts being complex, like having a huge, like many else, using else to like matching a lot of different errors, it will become a code smell. Let's show an example of that. Example here, we have these 2 matchings here that it can be difficult to know which clause is the error value this came from. The refactoring will be like moving this logic to function, like encapsulating this logic for each function. So we have here, for example, for this one, the error will be handled inside that function, inside that context, and same for the other one will be handled here. The other example is about the dynamic atom creation. You may be already aware about that. It's not a problem having atoms created dynamically, but it can be if it's like created dynamically without control. Atoms are those constants that are not garbage collected by a Erlang virtual machine, so we need to be careful to not let your application crash. So this is an example of creating dynamically the atom, and the refactoring is simply like using the 2 existing atom. And spoiler about the new release for Elixir. All this code smell from that research will be documented as anti-patterns in the Elixir 16, and it will be categorized in 4 groups: the code-related anti-patterns, design-related anti-patterns, process-related anti-patterns, and metaprogramming anti-patterns. I won't dive in those, but I recommend you to follow it. And one thing that Valin is trying to do is like keeping this structure about like having the name, describing the problem, having an example, and showing how to refactoring. The naming here is important. Similar to designing patterns, when we are naming things, we are promoting a common terminology, a common vocabulary between the developers, facilitating the communication. And the reference for that research is in that document. So think about what next things to think about code smells. When we are talking code smells, we are also talking about refactorings. There's our ongoing work about the catalog of refactorings for those specific Elixir code smells. This is already some publication, like some paper published about it. And when I was preparing this talk, I was thinking also about the tooling. We know we have Credo, that is super helpful, but not all the code smells are identified by Credo, not yet at least. And I think the next step is like improving the tooling to try helping the developers noticing those things, because sometimes it's not trivial. Sometimes you need to have the context. Sometimes you need to have a deeper knowledge in functional programming or in the Elixir context. Other things that I was thinking of, like maybe some AI could help us also get in the context, because there's some research about for some specific smells, the engineer level, like seniority, or the knowledge about the system is important to helping them to identify the issues. Like some issues are invisible for those without context. Maybe AI can help. And the last thing I was thinking, maybe we can improve also metrics. We already talked about cyclomatic complexity when we have like these multiple conditionals, like that multiple if-else or multiple function clauses. Credo already supports it, but I couldn't find a way of getting the metric I was expecting with like the same version using if-else and the same version use function clauses. Maybe you think that we can improve it in the future. And in thinking about other metrics, we already have in the object-oriented programming, the ABC software metric. And for Elixir and functional programming, maybe doesn't make that sense. We have a version of it, but I think there is some room for improvement. And just to close it. And we already talked about a lot of things, about the history, about the traditional and Elixir code smells, about why code smells matter when we are thinking about overtime, about some refactoring techniques. If you want to keep like one thing in mind, we are talking about understandability and changeability, and how those two characteristics, those two things matter. And when we think about how our daily life as developers, we read more code than we write. We spend more time understanding code than we write. And also another thing, so think about automated tests for supporting your refactoring process. It will be like the key for making more comfortable to improve it. Think about test coverage. It's not about having like 100% of your code tested, but finding places that it's important and is untested. Think about the test pyramid. And one last thing is refactor is not revolution. Like it's not that bunch of codes that we need to change all at once. We are talking about accumulative improvements that we do all along the time. And one last thing, we already talked about adoption. We are talking about a lot of cool things in Elixir, but how about talking about legacy code in Elixir? Like, I'm curious about how is your code base in Elixir? If they are already easy to change, or you're seeing some issues, maybe some code smells. It's a good opportunity to contribute to the Lucas Waggy PhD research. That's all. Thank you so much.